And we're back to recording. So I took a couple weeks break. I had a SD card fail in my lab, and I had to rebuild everything. And I rebuilt it with ESXi 6.5 and ran into a couple bugs. So it took a little longer than I would have liked. Apologies for that. I actually meant to have most of these videos done by now, but we will go ahead and keep trucking through this. Big thing in this this video is I wanted to go ahead and go through some policy set creation and configure profiling. So in my lab right now I have a bunch of ports shut off, but I have about 12 or so devices that are plugged in that should be able to be profiled. So I'm gonna go ahead and unshut the ports, and you'll start to see them populate nice. Now there's one phone that I bought off of Amazon. It's like a $30 piece of crap, like third-party phone that probably won't get a profile because it's just some weird brand. And I did that on purpose. I wanted to actually show how to create a custom profile to kind of trim that down a little bit. Rate range G10/13-24. Go shut. Now as we go unshut this, a lot of PoE stuff and other devices are going to come up. I have a bunch of Raspberry Pis and some other things sitting in that lab right now. So as we go through it, you'll start to see them come up. And let's see, probably starting a profile here in ICE right now. Yeah, so as you can see here, it's starting to profile as it comes up, you'll start to see more and more information. So give me a moment. Yeah, and right now it's failing authentication because my policy sets are really bare. So it's not checking any identity store except internal user, the default. So we're gonna go ahead and fix some of this, but give it a second. It'll get a lot more cleaner information in a moment. As things get powered up. But just a reminder of what my policy sets look like. This is the wired one, and as you can see here, it looks at all identity stores, but I believe that one is missing internal endpoints because it's just for user identity stores. And even if it gets authenticated, it's denied access. So we're going to go ahead and create policy sets that allow these devices to be profiled. So both my access points came up. One's a 3600, one's a 3700. A little bit more. And there's only one unknown, which I believe this is actually the phone. I have a Cisco phone as well, which if we click into the information, we can actually get a lot of information on this phone. So let's see. It's a 7961G. See that. Yeah, so this is a lot of the information we get from the probing, which is pretty nice information to get if you ask me. A second. Nice. Yeah, and my Raspberry Pi, I have one with Raspberry and one with Kali Linux on it. So first thing first, let's go ahead and start to create profiles on these. Now the phone that I was talking about that doesn't have a profile, that's the one that's showing as unknown, and we know the IP address is 10.1.100.52. So what I'm going to do is I'm going to go ahead and go into the actual endpoint and see what other information's on here. So let's look at the attributes. So the OUI is Inventec Multimedia Telecom Corporation. So let's go ahead and take note of that. and I believe this is the MAC address as well. Now I'm going to grab the IP address for this and do a scan on it from ICE. So let's go ahead and grab that. And if you go over to Work Centers, Profiler, and Manual Scans, you can actually put the endpoint in and do a pretty deep, intensive scan. Now this information is useful for gathering a lot of information for potential profiling activities, and we'll come back to this. But I'm going to go ahead and run the scan for now and have it start scanning. And in the meantime, I'm going to go back to the rest of my ICE deployment, and I'm going to start making profiles for the devices that we saw. So first thing first. Let's see. Let's go ahead and create one for approved access points. So if we go to Policy, Profiling, go to Logical Profiles, let's go ahead and add that. Approved access points. And there's a lot of preset profiles already that ICE consistently adds to in the profile feed, but we're going to just go ahead and use some of those for most of these devices. So first thing first, I'm going to grab 3600 and 3700. This is the logical profile for my approved lab access points. Let's see, what else do we have here? So we've got Android, Raspberry Pi. This is a little desktop Android device. And this is, Raspberry Pi is my Kali Linux. So add Pi. Actually, and so there's two Raspberry Pis. They're just running different operating systems. Let me take a look at this one really quickly. So to see why these two are profiled differently, even though they're both Raspberry Pis, we're going to go ahead and take a look at the information that was presented. So if you see here, it's still the OU is showing as Raspberry Pi, but DHCP request shows Linux. So on this one, you'll notice that the DHCP class identifier will actually show Linux, but if we look at the other endpoint, the Raspberry Pi one, got down to the DHCP classifier, no Linux. So it's kind of a weighted score. So if you look over here on profile policies and go down to Raspberry Pi device, it meets a certainty factor of 10. But if you go back to Linux workstation, which should be down here. So first it meets 10, and then it meets an additional 10. So it's weighted a little heavier to receive the Linux workstation profile. And that's why it was showing us both. Now, if we want to go ahead and have it weighted a little further and by all means have Raspberry Pi device also meet Linux workstation and make sure that they have the same profile, what we can do is do something like let's see, I can create a profile in here, and let me go ahead and show you how that's done. So let's go ahead and add a profile. And it's going to be Raspberry Pi Linux. Most of the time this is pretty accurate, but you have to understand it's a little bit of a weighted system, so you want to make sure that if it is going to be if you want it to be very, very specific, sometimes you may have to just kind of push it over the edge a little bit by having it weighted a little further. And let's see, create new condition. Mac OUI contains Raspberry Pi. Submit. So basically, if the OUI contains that, it will meet that that profile. So if we go back to endpoints now, let's take a look. There we go. It changed the profile almost automatically. So if I want to create a logical profile now with those just my Raspberry Pi approved devices, let's go ahead and do so. So Raspberry Pi approved. This is a logical profile approved Raspberry Pi devices. Let's just go ahead and grab the two that we created over here and push them over. Done. And we'll take these logical profiles and we'll create policy sets with them, and almost there at that point. But I want to make sure the scan gets through first on this guy because I want to show you some neat things we can do with that. So let's go back to the endpoints. So almost everything here we've got Raspberry Pis in their own logical profile. We've got this in our one. Android devices, we'll get to that, and we've got Cisco IP phones. So I'll just go ahead and create one for IP phones really quickly. Profiling. Oh, there we go. We got one for IP phones already pre-built. So let's go ahead and take a look back at that unknown device. And already we're starting to see so other attributes come up. Now this one would probably be an important one. This will help kind of create a deal breaker for it. So I'm going to create a whole custom profile based on this. So first thing first, let's go back to profiling. And let's also create something. So cancel scan, because I think we've gotten everything we need. And I'm going to create a custom scan based on certain custom ports. So TCP 5060 for SIP. We're going to save the scan action as SIP. This is a scan action to scan for the SIP port. Okay, so let's go back to profiling. Let's add a first thing that we'll do is Fentech devices. And we're going to go ahead and have the network scan action be SIP. No parent policy, just whatever the global settings are. So create new condition, and we'll just start with Mac OUI or Mac address. Starts with, then we'll have it start with the OUI. Certain factor of 10. Now the next thing we're going to do is condition Mac OUI contains Inventec. If it does contain Inventec, then take network scan action, which is the one, the SIP network scan NMAP action we just created. So I'm going to create that. Next thing we're going to do is we're going to create a child policy for that, which will be right under Inventec. Inventec phone. This is a profile Inventec phones. The condition is going to be NMAP. Let's see. Doesn't seem to be here, so it's fine. We'll just go ahead and add that port. Actually, I think it'll be back here. NMAP extension. There we go. Means SIP. Perfect. So now we have this nice little child policy, nested policy here. And I'm going to go ahead and add it to my logical profile for approved phones. And the only thing I'm going to add is not the Inventec devices. I'm going to just add the Inventec phone. So it has to meet both those criteria to pass. Save. Let's go back here to see if that's been reprofiled. Let's see. Let me just make sure I got everything correctly in here. Now, in my luck, I'd probably grabbed the wrong MAC address or something. Actually, I did. The MAC address is, I put in, okay, I see what I did wrong. So going back here, real life troubleshooting. So if I go back here, you'll notice that I put the wrong MAC address in there, and so I was looking for 01000114. It was actually not that. There we go. There we go. Now it's classifying as Inventec phone. Perfect. So, you know, select troubleshooting aside. Now everything that's plugged in has a device, a profile assigned to it. So now we create policy sets based on profiles. So first thing we want to do is we go to security demo wired, and I'm going to go ahead and start with creating a MAB policy. And all this does is saying, and remember, authentication does not mean you have access. It just means that we know who you are. The authorization policy is where we're going to create that access. So first thing we're going to do is we're going to go ahead and go, if it wired MAB, which is not .1x, we'll go ahead and allow the host protocol. And the only thing we really need to do is I'm going to create one that just does host lookup in ICE. So let's go ahead and uncheck all the rest of this. We don't need anything else here. Save. And the only thing it's going to be looking for is internal endpoints. And if the user isn't found, continue on because we'll do .1x profile, .1x next. So based on that, it will pass authentication. Now, we have to create authorization rules for it, and let's go ahead and show you kind of how to create a policy set. So, or I'm sorry, an authorization profile. First thing I'm going to do is I'm going to create, actually should be a default one for permit all traffic. So just going to use that. And I'm going to go ahead and actually, this probably is using the same thing where it's just permit all traffic. So I'll use that for phones, for Raspberry Pi. And you don't have to create whitelist. You don't have to create a DACL for every type of device you have out there. I'm just kind of doing it to show as an example. So Raspberry Pi whitelist, permit all traffic, or profiled, permit all traffic. For the IP phones, we kind of briefly showed it, but it's permitting all traffic and it's allowing the voice domain, which means the voice VLAN is allowed to be used at that point. So we got Raspberry Pi profiled. Let's go ahead and make a one for internet only, and that will be for the Android devices. So give me a moment. This will be useful later on for our guests as well. So first thing we want to do is permit UDP any equal boot PC, any equal boot PS, permit UDP any equal domain. So permit UDP source port is boot PS, boot PC. So that's for DHCP and DNS lookup. Then we're going to deny RFC 1918 addresses. So deny IP any equal any 10.1 or 10.0.0.0 255.0.0.0 deny IP any 172.16.0.0 and 25 was it? Brain farting right now. If I recall correctly, it's 5.240.0.0 and then 192.168.0. Deny IP any 192.168.0.0.25.25.0.0 and then underneath permit IP any. We can check the DACL right there and click save. So the next thing we're going to do is we're going to create an authorization profile for Android device profiled. We're going to only give it internet access only. Nothing else. So we've got phones, Raspberry Pis, and I think that was all the endpoints really I was looking at. A second to pull up. Oh, and we'll just create one for wireless access points. Actually, for wireless access points, I'm just going to go ahead and give them access to the controller only. See only. Permit IP any host. I haven't configured my wireless controllers yet, but we will when we get there. Perfect. Next up, let's go ahead and create add that information in our policy sets. So our default's deny. Let's go ahead and create a rule above. First thing first, let's go ahead and create one for phones. So approved phones. The logical profile equals approved IP phones. Then grant it the level of access that we created for the authorization profile for Cisco IP phones. Done. And let's go ahead and take a look what happens over here when we save this. So everything's rejected right now. Now it's just been given access. Look at that. Changed in a couple of seconds to approved phones. Now we're going to do the same thing for the rest of our devices. So let's insert run rule above, and this is going to be for Raspberry Pis. Create new group, or create new condition, endpoints, logical profile equals approved Raspberry Pis. We're going to create one for access points. We're going to give it access to the wireless controller only. Next up, we've got Android wired devices. Actually, I don't think we created a profile for this. I'll come back to this one. So we've got access points, approved phones, Raspberry Pis. So I think we're pretty good there. So let's just save this and watch the magic happen. Look at all that rejected. Watch the Raspberry Pi starting to get changed. Let's see. Should be hitting the new policy. So Raspberry Pi is now showing as granted access. If you wanted to kind of force some of these to re-authenticate, you can go to live sessions and let's see. I think this actually failed already, so probably lost power or something, but let me take a look. Let me go ahead and just bump the port really quickly. Usually it does it in a quick, pretty fast amount of time, but I don't want to make you wait on video, so let's see what happens if I just force this really quickly. Oh, looks like they're actually already starting to change. Yeah, I didn't even have to bump it the port. You start to see the ACLs start to apply. It's just going through the .1x failover first. So everything now has a profile except for Android, which we didn't create that policy, so I'll just go ahead and add that really quickly. So back to profiling. I'll just add it to the approved mobile devices. So just, oh, looks like it's right there. Perfect. So back to policy sets. Let's go ahead and give our approved mobile devices only internet access. Approved mobile wired devices. I'll just leave it at mobile devices. Condition, new condition. And we're going to give that guy internet access only. Now, what we can see it actually in the switch. So as you can see here, .1x failed for that mobile device, and when MAP failed over, it went to it downloaded the downloadable ACL of internet only. So if I do show authentication session interface, this is what which interface are you on? Oh, so right there, 1019. 019 detail. You can kind of see the story of what happened. Okay, so it was eventually authorized, and .1x it tried .1x first, which failed, and then it failed over to MAP, where the authentication succeeded. Due to that, it was able to download the ACL of IP internet only. Now, there's a couple different things you can do with an access authorization profile. I kind of skimmed through that, but example being, let's go ahead and take a look at the authorization profile. So we'll have our Android profile one be our guinea pig. So we can authorize voice always, change the VLAN even. So right now it's defaulted at VLAN 100. I'm just going to put in VLAN 30. You can force the vulnerability assessment, web redirect like a splash page, force MACsec. Aerospace ACL is more for the wireless controller, ASA VPN for ASA, AVC profiles, change some configs on the port. There's a couple different things. So I'm gonna flip the Android device really quickly and show you what I mean with the VLAN. So show interface G019, shut, no shut. Now it'll take about 10 seconds to fail over from .1x. That's my timer on the port. So you can trim it down a bit, but I wouldn't go below 10 seconds, for example. So do show run interface G10/19. So this TX period, that's the .1x timeout. I have it set at 10 seconds. It's kind of best practice, but you can always reduce that. Just don't go below 5 because it may take some like supplicants a couple seconds to kick in to be able to respond to the port. You don't want it to fail to MAP automatically. So now now we're going to go ahead and do show run, show auth session interface G0/19 detail. So you see now my new VLAN that we just picked was carried down to the port. So yeah, there's a couple different things you can do with this. It's pretty nifty, but if you wanted to make sure not have to reconfigure VLANs on ports, but bear in mind that some supplicants, the endpoints, don't automatically re-ask for an IP, or don't recognize that they've just been put in a new VLAN, and don't always ask for a DHCP address. It depends on how good of a supplicant it is. But dumb devices tend not to be too like some phones and cheap Android devices might not sense it. I believe Windows has something built in that does, but still sometimes it can get a little kludgy, so bear that in mind. With that, we're going to go ahead and end this video, and then I'm going to do .1x in the next video. Thank you guys so much for listening, and I hope you guys are learning a lot out of this.